PICO is an interactive tabletop surface that can track the positions of specially tagged pucks on top of it. Using an array of electromagnets, it can also move these pucks under software control. We developed PICO to explore the idea of mechanical constraints as a new way to interact with computers during problem-solving tasks. In this simple example, the computer is trying to form an equilateral triangle with the 3 pucks. When the user moves one of them, the computer responds by pulling all of the pucks toward restoring the equilateral triangle. PICO uses the physics of the interaction between the objects on the tabletop as a means to combine the behavior defined in software with the user's actions. The user can constrain the motion of any of the pucks with his or her hands or any other physical object. In this cellular telephone tower placement application, the goal is to maximize the overall network coverage by moving and reconfiguring the towers. The user can associate each puck with a cellular telephone tower and place it at a desired location on the map. Even as the user pans and zooms the map, the motions of the pucks remain consistent with the software representation of each tower's current position. The computer autonomously tries to move the towers to optimize their location using a simulated annealing process, while the user can guide the optimization process using mechanical constraints, like this flexible barrier. Next, we'll look at some more examples of mechanical constraints. One can lock an object in place just by holding it, or by placing a weight on top of it, making it too heavy for the computer to move. This roll of tape allows the puck to move freely within a limited area. These collars ensure a certain minimum distance between pucks. As mechanical constraints are added and taken away, the computer continues trying to optimize the overall layout of the cellular telephone towers. This barrier confines the puck to a user-defined region of the table. A ring ensures that these 2 pucks stay within a certain maximum distance of each other, and the optimization continues within this constraint. These constraints can be combined as desired. If one places a lighter weight on top of a puck, the puck will be more reluctant to move than other pucks, making its associated tower position more difficult to change in software. The opposite effect can be obtained using a slippery material like Teflon. Here, we use some soap and water as a lubricant to make towers on a specific part of the map easier to move. The variety of physical objects that can be used as mechanical constraints in PICO is quite large. In the context of an application like cellular telephone tower layout, these mechanical constraints serve to balance the computer's brute force quantitative optimization with the user's intuitive understanding of subtle issues that may be difficult to quantify.